transformations of functions. So if we have a plus 5 on the end, it means the whole graph is going to move up 5, so it will now go through at the point 3, and it will be the exact same curve. If we have a minus in front, it just means the entire curve goes upside down, so it will still go through at the same point 4, but it just goes in the opposite direction now. Again, minus 4 on the end means that we're going to move down 4, keep the same shape curve, but 4 lower. If we have a minus 5 inside a bracket, it means we're going to move left or right, and it goes right for a 5, for plus, so it will go through at 0, and then keep the same shape. These are all sketches, so don't worry how accurate they look, as long as they show what they need to show. We have minus x cubed already. Minus 2x cubed means it's going to get steeper. Be careful here, there's already a minus, so we don't need to flip it for this minus that's there. If we have a minus 3 on the outside, it means the whole thing shifts down 3 and the rest of the graph stays the same. Loci, some of these might not work particularly well because they are shrunk down slightly to fit on the page, but we'll have a go anyway. Points are nearer to the line AB than the line DC. So to make sure they're nearer, we're going to have to find out how long, what the gap is between, and then find half of it. This, my guess, should be 4 centimeters, but it comes out as about 3.5 when it's shrunk. So everything above that line is going to be closer to AB. Less than 6 centimeters from the point A, I'm going to set the compass to 6 centimeters. I'm going to place it on the point A, and I'm going to draw a circle. So less than 6 means they're inside the circle, and nearer to AB means they're above this line, so it's all the points within that section. Points are nearer to BC than to AB, so BC, AB. That creates an angle here, which I'm going to split using the angle bisector. So I set the compass to whatever size I want, I place it on point B, and I mark this line and this line, and then from those 2 points, I mark in the middle, and again in the middle here, and then I take pencil and ruler and I join up where they crossed with the angle, and I've now split that angle in half. So everything below the line is close to BC and everything above will be closer to AB. Less than 5 centimeters from B, we would draw a circle of 5 centimeters around B, and as you can see here, because it hasn't been shrunk, that makes it, so I'm going to make it smaller just so you can get the idea. Less than 5 means inside the circle, and closer to BC will have to be these underneath. Less than 4.5 centimeters from A means I'm going to measure 4.5 centimeters on my compass, and then I'm going to draw a circle around A. So just a nice circle around A. Everything within that circle is less than 4.5 centimeters from A. Nearer to B than A, I set my compass to be more than half the line, and I do a little mark above and below, and I repeat this process from the point A. I mark below and I mark above, and at the 2 intersections of those points I draw a straight line. So I need to be closer to B, which is this side of the line, but less than 4.5 centimeters from A, so it's within that section there. Nearer to AB than to DC, so AB than DC, so this is another case of measure the gap and then mark halfway between, mark it in at least 2 places so that you get an accurate straight line. Mine's not very good there because it's quite hard to measure half because it's not quite accurate because it has been shrunk. Less than 6 centimeters from C, so set your compass to 6. I'm going to use slightly smaller again, put it on C, draw the circle. So closer to AB means above this line, and less than 6 needs to be inside that circle. Pythagoras Theorem. Triangle PQR is right angle triangle. The length of PR is 12.3, so this is 12.3, and the length of PQ is x, and the length of QR is 2.1. Show that that's true for Pythagoras' theorem. So Pythagoras' theorem tells us that 12.3 squared is equal to x squared plus 2.1 squared. That, oh, made a mistake there, 2.1 longer than PQ, so this means it's 2.1 plus x. So this is 2.1 plus x all squared. So expand what we can. 12.3 squared is 151.29. X squared is just that. And then this is going to need FOIL to expand it. So we will get x squared plus 2.1x plus 2.1x, and then we'll get plus 2.1 times 2.1 on the end, which is 4.41. So this bit here is x squared plus 4.2x plus 4.41. They want it equal to 0, so I'm going to take this over. So I'm going to get 0 equals x squared plus x squared is 2x squared plus 4.2x, and then I've got plus 4.41, and I'm going to subtract 151.29, which gives us minus 146.88. I'm not going to bother solving this because actually we've solved that earlier on in this booklet on the quadratic formula section. Calculate the area of the trapezium ABCD. So the area of a trapezium is the top plus the bottom divided by 2 times by the height in between. Obviously we don't have the height in between, and that will be this length here. What we do know is that that's 8.2, and we can also work out this by here because it's the 19.7 minus the 13.4. So here we've got 6.3, and then Pythagoras' theorem will work out x for us. So Pythagoras' theorem tells us that 8.2 squared is equal to x squared plus 6.3 squared. Take the 6.3 squared over, so 8.2 squared minus 6.3 squared is equal to x squared. And then we get 106.93 is equal to x squared. Square root that value, and we find that 10.34 is equal to x. Then we can use the formula, which is a plus b divided by 2 times h for the area of a trapezium. So 13.4 plus 19.7 divided by 2 times by this 10.34 we've just worked out. Work this out. And we find that the area in total is 171.2127 centimetres squared. Last one, I think. In the diagram ABC, AB is 65 and the diagonal, calculate the perimeter of the rectangle. So again, we need to find the height of this rectangle. So Pythagoras' theorem tells us 90 squared is equal to 65 squared plus x squared. So 90 squared minus 65 squared is equal to x squared. So we find that 3875 is equal to x squared. Square root that, we find what x is. So 62.25 is x. So then the perimeter will be 65 plus 62.25 plus another 65 plus another 62.25. Add all them together and we get 259.5 centimetres for the perimeter.